Today's video will be about heating and cooling curves. We're going to start with a problem. The problem states how many kilojoules are given off when 120 grams of H2O are cooled from 25 degrees to negative 25 degrees. So when solving a heating and cooling curve problem, there are two steps involved. The first step is using the formula Q equals mc delta T. The second step is using a process involving thermal stoichiometry. Depending on your problem, these steps could be repeated a multiple amount of times. To start, I'm going to draw an image. This image shows that water turns from liquid to solid at 0 degrees and goes from a liquid to gas at 100 degrees Celsius. So in our problem, we read that the 120 grams of water start at 25 degrees Celsius, which would be located around here on our little line graph, and go to negative 25 degrees, which would be located about here. So when doing this problem, there would only be 3 steps. There are 3 steps because you are going from negative 25 to 0 degrees. You are going to 0 degrees because that is where a phase change happens. A phase change is happening, which means that you would be doing a thermal stoichiometry problem. This would also be Q2 in your problem. Before this, you are just changing your temperature. This is your Q1. And after changing your phase, you go from 0 degrees to your negative 25 degrees. This would be your Q3. Your Q1 and your Q3 are both Q equals mc delta T problems. So let's start with doing one of these Q equals mc delta T problems. We'll start with Q1. To solve, all you do is plug in the given information into the equation. Your mass is 120 grams. Your specific heat, or C, is 4.18 joules over grams degrees Celsius, and your change in temperature is negative 25. It's this because your final temperature is 0 degrees, and you're going from 0 degrees, you're going to 0 degrees from 25 degrees. This is also known as your final minus your initial temperature, of course. So after plugging those numbers into your equation, you put those into your calculator and end up getting negative 12.54 kilojoules. And that is your Q1. So we can now skip to Q3 because this involves the same process, Q equals mc delta T, and we'll do Q2 after, which involves a different method. So for Q3, you just plug in your information again. So your mass is still 120 grams, but instead of having a solid specific heat, you will be having a liquid specific heat, which would be 2.02 joules over grams degrees Celsius. And your change in temperature would be negative 25 degrees Celsius. So you plug these numbers into your calculator and you would get negative 6.06 kilojoules. So these are your Q1 and your Q3. So what's next? Q2. This is a thermal stoichiometry problem. To do this, you start with the information you know, which right now is grams. So you know that you have 120 grams of H2O, and in one water molecule there is 18. In 1 mole of water there's 18 grams of H2O. 1 mole, 18 grams. So there's a mole on the top, so there has to be moles on the bottom. 1 mole of H2O for every negative 6.01 kilojoules in a solid high water molecule. You get this number from the table given on your problem. Once plugging all of your information into your stoich, you should be left with negative 40.07 kilojoules. And this number right here is your Q2. So you have now gotten your Q2. Well, we'll say you've gotten your Q1, your Q2, your Q3, and that's it. So you can now find your total. All you have to do is add all the numbers that we found. So our Q1 was negative 12.54 kilojoules. Q2 was negative 40.07 kilojoules. And your Q3 was negative 6.06 kilojoules. Add this number up, and the total amount of kilojoules given off when water goes through these phase changes and temperature changes is negative 58.67 kilojoules. And that is the total kilojoules, given off when 120 grams of water goes from 25 degrees Celsius to negative 25 degrees Celsius. Thanks for watching.